So it's like a double effect. You have the CO2 circulating through that system, and you have, I guess, now bear with me here while I'm trying to learn this stuff. So you have it pumping somewhere, and you have some expansion there, and coming back, just like a refrigeration cycle with another refrigeration cycle. Am I understanding that correctly?
So you use solenoids, and so as the temperature starts to rise, the solenoid would open. It would let the CO2 through the coil, and as it goes through the coil, you're getting sensible heat, but as well as you will get some latent heat transfer in it, where glycol is only sensible heat. And yes, it's a second medium, so you're just pumping that through, and then it comes back to the main pump station, and then you'll have like a plate heat exchanger there. And as it goes through there, you have a primary side. So you'd have the primary refrigerant, say is 134A, 404, 448, 449, one of many refrigerants, R290. And what it'll do, it will drop the CO2 into this big vessel, and that vessel will be connected to a circulator, and the circulator would push the refrigerant through.
All right, let's go to the next part where I don't know what I'm talking about. Okay, so you said solenoid valve opening up, CO2 is going into an evaporator. Is it metering in any way or just opening fully?
Just opening.
Okay.
Well, there'd be inside there's certain size of solenoids, because you need to size them properly. Because this is one thing about I've seen a lot when I worked for Emerson, because I used to train all the wholesalers, and a lot of people would just size it on the line size. It's 5/8. I need a 5/8. Well, there's 3/8, 5/8, 7/8 of all the same tonnage. You don't just need 5/8. You need to understand the reasoning why you're using a solenoid valve. Okay, so it's no different in CO2. So
that's interesting. That's really interesting. I would use the 5/8 probably, but then again, like I said, I don't know what I'm doing. So you could potentially have to use a smaller solenoid valve. Does that somehow? I don't know. Not typically metering, but is it somewhat metering, being smaller than the line size?
No.
Okay.
No, you'll have a different MOP maybe, so maximum operating pressure differential. But I've seen going from, especially on electronic valves, going from like 1.5", so all the way down to like 7/8, and it's getting your tonnage that you need. So
that's really interesting.
1-in-1. Because that blew my mind the first time I seen it. I'm like, whoa, pressure drop, what's going on here? And then it may go back up. Usually it doesn't, but depending on the application it's in, though, because I've seen it that way.
Interesting. But a design pressure drop nonetheless.
Yeah, there will be some pressure drop, I'm sure. I don't know the exact engineering numbers.
Well, we'll hold on here for a minute and go. No, I'm just kidding.
Yeah.
Let's call the people who do that.
And, do it. Call them. Let's talk to them. Get them on here.
They're already here. Here you are.
Let me know. Tell me.
No, just for the last part of my understanding, which I have to believe that at least there's one other moron like me in the chat that's going like, that is a good question. So you have this CO2 being pumped out, and you have this other refrigerant outside, and the reasoning the CO2 isn't the refrigerant outside is because of the temperature in the environment outside?
So outside, you're using that synthetic refrigerant. So the primary side is a different medium. It's a different refrigerant. And that one there would have your condenser, say, outside. So it'd be a normal refrigeration system. But the evaporator for that would be like the condenser for that CO2 side. Just a quick example.
But why not use CO2? Why use the other refrigerant?
Okay, well, depending on where you're at in the world. When you use CO2 in high ambient locations, it costs there's a lot of penalties. We talk about COP, energy cost. So you have to add different technologies to make it more efficient. And over the last 15 years, a lot of the manufacturers, contractors have been developing things for high ambient strategies. So you could have a CO2 transcritical system in Phoenix. That's the way it was done before. It's still done in tons of industrial with ammonia. Ammonia goes through plants and more cascade or secondary pump systems. But you will see going forward more and more full CO2 systems.
Oh, that's pretty cool.
Because of regulations, environmental concerns, and things like that.
That's a good point. Environmental concerns. So the GWP of this is like what, 1? or 2
Look at
or
you.
something?
You know your stuff. You're like an
Oh,
expert at CO2.
Yeah. Okay.
Yeah.
All right. All right. Now you're insulting the intelligence of the entire chat. No, GWP maybe. The rest of the stuff you just said, no. I'll work on that later. I'll get a book that has pictures, and I'll read about
boy.
that. No, but I know it's just a natural refrigerant, really low GWP, but it is almost nothing. Correct?
Yeah, it's one. It's the baseline, and the thing about it, it's like the most efficient refrigerant. Like it's the net refrigeration effect is skyrocketing, like way above 404 and all the other refrigerants. The only other one that's really above it's ammonia. Ammonia has like the best net refrigeration effect, and that's why it's been used for 100 years. But people are scared of that too. Oh my God, it's ammonia! It's dangerous. It's toxic. We've been using it for hundreds of years.
That's true. And now we have other hydrocarbons like propane. So, all right, let me ask you this: since we have propane, GWP is really low, and it doesn't explode at all. I'm just kidding. Ammonia's got the same problem, but if you're using something is developed in the future for your home, is it likely to be propane or likely to be CO2? Think in the distant future. What would you expect to see?
No refrigerant at some point.
I like this. What's going to happen? We're going to have some sort of like nuclear powered air conditioner
I don't
sits
know.
outside and floats.
But I really think at some point we'll have some sort of technology that we're not going to use refrigerants at all. Yeah, I don't know what it is.
Boldness. I like that.
But the compressor, I've said this at Copeland when I was even working there, like who's coming up with the design where you don't need a compressor anymore? It's already like there's things out there, there's technology out there that's already doing that on really small applications, but at some point we're not going to need this stuff. Have you ever watched Star Wars and Star Trek and all these things? Technology keeps evolving. Hoverboards from the Back to the Future, there's hoverboards now. It took a little longer
It's
than
like
they
7
said.
years too late on the hoverboard.
Yeah, but it's here. You know what I mean? So it's not going to be different with this. We're going to come out with technology that's going to replace refrigerants because it is very harmful for the environment. Climate change.
I'm curious because at Emerson, the day you said they didn't need compressors anymore, is that the day they decided to say, man, you got to go work somewhere else now?
Yeah, that's like, Trevor, you're out.
If you want to watch more videos just like this one, click on this playlist right here. If you want to see our brand new video, click right here. If you want to find out more about the great sponsors that make this show happen, click up here. And to join our email list where I notify you when we're going live, click right here.